Hey everyone, in today's video we're going to be going over the problem maximum performance of a team. And this problem is part of the first week of the June Leak Coding Challenge. And so yeah, let's just get right into it. So this problem gives you two arrays essentially, speed and efficiency, and they're both of length n. So n equals 6, they all both have 6 elements. And speed I and efficiency I will represent the speed and efficiency of the ith engineer. So the 0th engineer will have a speed of 2 and an efficiency of 5, etc., etc. So you're given a number k, and this is the amount of engineers you can pick out of this group of engineers, and you want to maximize the performance of them. And the performance is defined as the sum of their speeds multiplied by the minimum efficiency among them, right? So looking at their test case here, you can select at most 2 engineers. And this is important because in some test cases, they give you one really efficient engineer who's like really fast. And obviously you want to use him, but then the next engineer is like, has like an efficiency of 1, let's just say. And since you're multiplying by the minimum efficiency, that'll decrease the answer by a lot. And since you're trying to maximize the performance, sometimes it's better to not choose all K engineers. Like sometimes even though you can choose 3 engineers, it's just better just to choose one, like the best. But that's just an important wording on their part. And so in their test case here, if you select, since you're allowed to select up to 2 engineers, the combination of the second engineer and the 5th engineer will result in the largest like performance, right? And you would calculate it just by uh, adding up their speeds here, taking the minimum of all their efficiencies and multiplying it together, right? And this is the logic with 3 different engineers. Yeah, so let's get into solving the problem. So I mentioned this in a previous video for maximum area of a piece of cake after cuts, but the first thing you notice here in the constraints is that n is less than or equal to 10 to the 5. So we know we want to use n log n runtime of solution, right? Sorry, let me just, all right, I'm good. Okay, so yeah, so uh, let me just go into explain the solution, right? So what we want to do is we want to uh, try having each engineer be the least efficient engineer. So what do I mean by that? So essentially, uh, we we know that no matter what group of engineers we select, like this team of K engineers, one of them will be the least efficient one. And so what we can do is we can, let's just say we have our array of engineers here, each with the speed and efficiency. We can sort them by their efficiency. So the most efficient engineer starts at the front and you can just go back, right? And so uh, after sorting them, you can just go through these engineers by their efficiency. And so for each engineer, let's just say we look at this one, we try adding him to the team. So we know that this guy here will be the least efficient guy on the team. And so we know that whatever engineers are over in front of him, we know they're all going to be more efficient, right? So the minimum, their little function here of all those engineers will spit out the efficiency of this guy. And since we know that this part of their equation, which you can see here, will spit out the efficiency of this guy, then we can just find the other part of their equation pretty easily, right? Because performance, you just add up the speeds. What we can do is we can just find the fastest guys. We can find the fastest guys out of this group here, and we can add those together to find the speed, right? because let's just say you can select like k people. Let's just say k equals like 5. That you know that this guy will take up one guy on the team, so you just want to find the 4 fastest guys here, because we know the efficiency of the min will be this, and multiplied it, we have the sum of the speeds here, and we just want the 4 largest values that are in here. That these 4 largest speeds that any of these engineers can have, and shove them into this part of the equation, add them up, and that will give us the performance of the best team with this guy as the least efficient guy. And we'll just keep on going. So we'll check this guy's the least efficient guy. So now this guy will be part of this group. So we can shove this guy's efficiency into min and pluck out the 4 best, the 4 guys with the highest speed. So we can maximize this sum, here in front of this equation, and that will return the maximum performance you can get with this guy being the least efficient man on the team. And so this logic makes intuitive sense, of course, because if you try using this guy as the least efficient, you know all these guys are going to be more efficient than him. So you can just find the fastest guys to make this part of the equation as large as possible and calculate the best performance you can get. And you can just go through the list of engineers and try having each one be the least efficient man on the team, and that'll essentially calculate all the different performances, and you just need to choose the best one out of all of those. And the only other detail, which builds on what I mentioned earlier, is that if you can choose 5 engineers, you might not always want to choose 5 engineers. So because let's just say this first engineer here is very, very good. He has an efficiency of like 100 and a speed of like 100. This guy here immediately drops to like a speed of 3 and like an efficiency of like 3 as well, let's just say. You don't want to add this guy to your team because this guy alone, he'll make be the best performance, right? So for the first K, like uh, people, you still want to check if the group with these people will, like, let's just say you can choose up to 5 people. You still want to check if choosing the 3 most efficient people or the 2 most efficient people or just the most efficient person or even like the 4 most efficient people might you still want to check the performance of those teams because they might just be the most efficient. But after the 5th person, you know you always want to have a group of 5, right? Because um since this part here, the efficiency is already determined by the efficiency of this guy, you know you want to pick out 4 other guys from the previous people because you're just summing them. So because all the speeds are positive numbers, uh, you know no matter what, you want to take all of these, even if they all have like a speed of 1. Since you're summing them up in this part of the equation here, it doesn't matter. You'll still be finding the team with the best performance. So after the kth member, you know you want to always be trying out to select k members. But before that, you want to try if the first guy alone is the best, or if the first 2 guys are the best, all the way up to if the first 4 guys are the best. And then you can use that logic of, if I add this man to be the 5th man of the team, what's the maximum performance? And then if this man is the 5th man of the team, what's the maximum performance that you can get? And so this will essentially find the best performance of each group where one guy is the minimum guy on the team. And we can use a priority queue to be able to find the in this case, since we want to find the 4 fastest guys out of this to maximize the sum, we can use a priority queue to find that in log n time, and that's perfect for our situation because we want our runtime to be n log n. And so yeah, let's just get into let's get right into how to implement this. So first of all, we can I just made a class called engineer, and of course we want to be able to sort these engineers by their efficiency. So we have an implement comparable. That just means we need to tell it how to compare it to another engineer. And because we want to sort it in descending order, we will just return the other efficiency subtracted by this efficiency. And so if you don't know, sorting it in ascending order, which is natural, you just want to say this the value in this class subtracting the other one, but doing it in this order, we'll sort it in descending order. And just a regular constructor here. And so we will have an array of engineers here, and we will loop through all the engineers. So the ith engineer here will just be an engineer with a speed of that and an efficiency of that, right? And then we can sort the engineers. So now we'll have the engineers in order of most efficient to least efficient. And now we can have a priority queue and a sum. And this will help us track the maximum sum of speeds that we want here. So this priority queue will be holding the speed values of the current fastest k guys, k minus 1 guys in this front area here. And the sum will just represent the sum of all the speeds in our priority queue. And since our priority queue represents the speeds of these people, um, the sum will be just this sum here. So now what we want to do is we can just first have a for loop looping through the first cases, right, where we choose less than k people. So yeah, so we will start from here, and every time basically in this loop we're checking, let's just say this is I. We just want to take the ith engineer and everyone before him because that's just our best case scenario at that point. So this will be the performance. So this long t, this represents the performance, and we can just calculate that by using our sum, adding the current engineer's speed to it, and then multiplying it by the current engineer's efficiency. And if it's greater than the max, we will set max to it, and then we will add this guy's speed to the sum and put this guy's speed into our list that tracks the current fastest guys with the fastest speed. And so as soon as I equals the k minus 1, then we know that now will this guy will be the kth engineer to the team. So because if we have like k equals 5, for instance, actually let's just make it like k equals 3, we'll have 0 and 1, but as soon as we get to index 2, we know that adding this engineer to the team, this guy will be the least efficient man on the team, and this guy will finish off the team because he will be like the third member. So this will just be a little bit different logic. So we can just put this in a different loop, right? And so yeah, so I have a comment here that this ith engineer will be added as the least efficient of the group of k. And so here we will calculate their performance using exactly the same logic as above. And this is the same. And this is the only new part. So yeah, let's just focus on this part for now. So if this current engineer's speed is greater than the slowest guy in front of him, then we want to take that guy out, subtract it from the sum, add this current guy in because we know he's faster, and then add that to the sum. So then we know that when we, let's say we put this guy in, when we go to the next guy, we'll know that we'll already know the fastest people in front of him, because we just inserted this guy into our list of like fastest people, right? And this check here just checks that we actually have people in our priority queue, because if k equals 1, our priority queue actually won't contain anything, because our priority contains the k minus 1 fastest people, and we'll add this guy as our like kth person, so we'll have a team of k people. So then this pq.peak will have like a null exception, so we just want to make sure that there's actually things inside of our priority queue. And so then with this logic, our priority queue will always be tracking the k minus 1 fastest people in front of our current engineer that we're adding as the least efficient. And our sum will just always be tracking the sum of our numbers inside this priority queue. And so after checking every engineer, after using every engineer as the least efficient of the group, and we know that the max will be the answer, we can just mod it and cast it to an int and return it. And to analyze the runtime here, this will run in n log n runtime, which is perfect for n equals 10 to the 5, because these for loops essentially loop through the array of engineers once, and for every loop it performs a log n calculation, because adding and removing from a priority queue take our log n operations. So this essentially will be n iterations in this for loop using a log n operation each time. That'll be n log n, and of course the sort here is also n log n. So the overall runtime is still n log n. And yeah, so that's about the end of this video, talking about the solution to maximum performance of a team. I hope you guys enjoyed. Thank you very much for watching, and I'll see you guys later. Bye.